start recording here. So we will continue with the notes are the last two sections here. Does anyone have any questions for me? Anyone have any questions? Homework.
Yeah, I got questions about some notes. Are you going to be available so anyone can pick up some notes today? Like not the notes without
the
the
blank
on.
notes is already on outside my office though.
Come again.
My blank note is
What
already
about the
out.
what about the ones without like that aren't blank, that are not blank? The ones
You
that
have to that one you have to download yourself.
download them. We have to download
it's in D2L. Yep, it's in D2L. So go to D2L and go to materials and content and go under instructor notes. It's in here. Yep. Or you can go to D2L if you want to go again, these notes are from last semester. So if you go on to the D2L announcement, the attachment that you see here, these are the one that we did in class. Yep, so you do need to download it. Yeah, I'm not going to providing this. You have to do it yourself. I can provide you the blank one, but not the written one. Is that what you're asking for? Right. So yeah, you have to do it yourself here. So it's all in D2L here. So which is this kind of notes. Yep, you have to go to D2L to get it. So we will continue with this 2.1 frequency distribution here. So last time, yesterday, I teach you guys how to figure out identify the class width, the class midpoint, the class boundaries, and then also do what we call as a normal distribution. So today we will revisit this again in question 2. But before we continue the question 2, we have a little bit more left on the frequency distribution. Okay, so as I mentioned, this table that you got here is called frequency distribution because it has what we call as classes, and then we also have frequencies. Okay, we also have another type of frequency distribution. We call that frequency distribution as a relative frequency distribution. My line is not drawn straight here. It's called a relative frequency distribution here. What is a relative frequency distribution is this relative frequency distribution is we do not use frequency. We will change the frequency to become percentage. Okay. So every time when you hear the word relative in statistics, that means that we will not report the frequency. We will change it to percentage. If you sum all the percentages, you should get around 100% plus minus 1%. The reason why that you get this plus minus 1%, you guys know that when you add all the percentages should be 100%, but sometimes you get like very close to 100, like 99.9 or 100.1%. So you got a little bit more or a little bit less than 100%. The reason why we get this plus minus 1 is because of rounding errors. Sorry, this is hard to write here, so I'm going to type actually. So this is due to rounding errors. So what do you mean by rounding errors in this case? Rounding errors means that when you guys convert this into percent using your calculator, you got all those decimals and you just round into 1 or 2 decimal place. Once you keep on doing these roundings in your percentages, you will end up having what we call as a rounding errors in this case. So I will, so it's all right. It's okay if you get 99.9% or 100.1, a little bit less, a little bit more, then you'll be fine because of rounding errors. However, if your sum of the percentages is not close to 100, let's say you got 125%, or you get an 80%, which is less than 100%, way less than 100%, then if you got that case, then we will say it is not a frequency distribution. Okay. So this is only happens when your sum is not close to 100%. The reason why you get 120, 130, your percentages is above 100% is because someone voted twice, someone raised your hand twice, or someone put into two of these frequency classes. So that's why your sum is over 100%. The reason why your sum is less than 100%, like 80% or 90%, is because of the sum. Someone did not vote, someone didn't participate. So that means that when you add all the frequency, maybe three of the students did not participate in the survey, then the sum is going to be definitely less than 100%. So if such thing happens, then we do not consider that as a frequency distribution. Okay. How do we calculate change from frequency to become percentages? It's very easy. So this is the formula. In order for us to change the frequency to become percentages, you take the class frequency over by the total, the sum of all the frequencies, multiply it by 100%. Okay. For example, we can change this frequency to become percentages. How do we change these frequencies to become percentages? Is first, you have to total up all your frequencies, which we know the total in this case is 91. And then in order for us to figure out what is the relative frequency distribution, you take each frequency that you have here over by 91 and then times 100%. For example, I'll show it to you. 1, which is the first frequency we have for the first class, divided by 91 and then times 100%. So this is around 1.1%. Now, depends on how many decimal places you want to round. If you round it to 2 decimal places, then make sure every single percentages that you're gonna do here is 2 decimal places rounding. If it's 3, 3. If it's 1, 1. I'm gonna round into 2 decimal places. As you guys know that if you look at the third decimal place, which is 8, which is high enough to round up, so the 9 will become 10. So that means the first one in this case will give us 1.10. Again, pardon this is difficult to do. So that the rounding errors that I mentioned early on is this case, because we don't use the whole full decimals, we start to round them. So when you keep on rounding every single decimals, you will end up with what we call as an rounding error. So that's why when you add all this up, you won't end up to be 100%, which is fine, which is okay. So if you want to do the relative frequency distribution of the second class, you just take 29 divided by 191. That's the total, times 100%. That will be 31.87. Okay, so again, I put this in 2 decimal places. And what you guys need to do is you just need to continue doing this, keep on doing this 38, 16, and so on, so on. I know this one is 1.1 because we redid the 1 already. That is the same one as the one that we have above. So, and then when you add all these percentages up, that will add up close to 100%. So if you combine these classes and the percentages that you get here, this is what we call as a relative. Okay, relative frequency distribution in this case. Quite important here. You guys need to know a little bit of it. Okay. So anyone have any questions with the relative frequency distribution?
Where does the 91 come from again?
It's a total. So if you add all these frequencies, you get 91. Questions? So that's why you have to sum all your frequencies here. Okay. Now, the next one that we have, also another frequency distribution, is called the cumulative frequency distribution. Okay. What is the word cumulative frequency distribution? As you guys know, cumulative means you keep on adding from now till the previous. So for cumulative frequency distribution is where you add all the frequency of the class and all the previous classes. Okay. So example that I always use for this example is like snowing. Let's say today, not today, like let's say in winter, let's say today is winter right now, and you got 2 inches of snow. And then let's say tomorrow you get 3 inches of snow on top of 2 inches. So how many cumulative snow we have? You just add, right? 2 inches yesterday and 3 inches today, total of 5. So that's cumulative. So for today. And then for tomorrow, you just add, let's say tomorrow we got another 1 inch of snow. So you accumulate 2, 3, and 1, you add them up. So what happens to this cumulative frequency distribution is very similar to what I just told you about the snow accumulating up. So you keep on adding from what you have today, which is the current class, and also add with those previous classes. Okay. However, you need to know this is when you do your class, this is super important. I'm going to highlight this so you guys will see this in here. When you do your class limits, you have to replace it with the word less than in this case. So that means that in your class, you cannot use the same classes that you have found when you do your frequency distribution. You have to use a different frequency classes in this case. So what do I mean in this case? Okay, so I will give you an example here. So let's say that we are still using the same examples of these actors and the frequency, the same example for the first example. So this is still the same context, which is the age of the actor in this case. Okay, but for the other case, we don't use frequency. We will use cumulative frequency. Okay. Now, for the first one that we have, you see in the classes is 20 to 29. So you do not use 20 to 29. You use less than 29. Okay. Or should be less than or equal to. Should be, this is the wrong word. Should be less than or equal to. Okay. So in other words, you can use this symbol, less than or equals to 29. Where is the 29 comes from? The 29 comes from the upper class limits. Okay. And since we only have one frequency, so that we only do one, we don't have any frequency classes before that, so you cannot add. Okay. For the second class, is 30 to 39. So this we will use less than or equals to 39. Now this time you can add. So you're gonna add the first class and the second class. So this is 1 plus 29, so it will be 30. So what I'm doing here is called the cumulative frequency distribution. You find out that the classes is a little bit different from the one that we have early on, that we do frequency distribution. And the reason why is because this 30 cumulative frequency actually accumulate from 20 to 39 because you add these two classes. So that's why it goes from 20 to 39. And then the next one is going to be less than or equals to 49, which is the upper class limit of the third class. And for this case, you have to add these three numbers, which is 1, 29, and 38. Let me add it up. 1 plus 29 plus 38. You got 68. So that will be the next one. And so on, so on. Again, I don't have time to do it. And we can tell that at the very last class, which is 79, the last, the sixth class in this case, the total should be 91. Because why is 91? Because we know the sum is the all is up is 91. So this is what we call as a cumulative frequency distribution. One important note about this is do not use, I'm going to type this out because it will be quicker, write it up. Do not use the percentages. So I got a lot of students do this in the test and they got it wrong. It's because instead of using the frequency, they use the percentages that you calculate on the relative one. So they use 1.1 and then you add 1.1 with 31.8 and then you add and add and add. That will be considered wrong. Okay, so please do not use the percentage numbers when you calculate the cumulative frequency. Otherwise, you end up with wrong answers. Questions here, anyone? With the cumulative. So this section, you will learn 3 types of tables. One is called the frequency distribution. This is just a normal frequency distribution frequency table that we draw. Okay. And then today, you will learn what we call as the relative frequency distribution, which where you use your percentages in this case. And then the third one, you will use the cumulative frequency distribution. So make sure you guys know these 3 are a little bit different. Now we can look at question number 2. Okay, so this is what you will get something in my midterm. So I will say that this question 2 is your midterm questions. Again, when I say this question 2 is the midterm question, it's not exactly like this question, but it will look very similar. Instead of using, and it's a different data set, in other words, but I will ask you for the same thing. So please pay attention for this one. This will be in your midterm as your open-ended. Okay. So as you guys remember that in your test, you have the multiple choice and you have open-ended questions. And what are open-ended questions? These will be your open-ended questions where you have to do a lot of work on it and you have to show your work, like what we do in example 1, example 2. These kind of examples are what we call as open-ended questions, where you have to do quite a lot of work on it and it will give you quite a lot of points. Usually, like one question like this is going to worth around 10 points. Okay, so make sure, that's why pay attention here. So refer to data set 36 fast food. Use the drive-through service through the burger time lunches. Okay, so this is super important here. So in this case, you have to go into the data set 36 fast food. Now, where can you find this data set 36? You have to go into your StatCrunch. Remember, in your My Stat Lab, in your homework here. I still have a few students have not registered yet to the My Stat Lab here. So I really recommend you guys to start doing this, because you do have like 5 sections of homework due on this coming Wednesday, next week, next Wednesday. So make sure you guys work on it. So so when you hit on the StatCrunch, there is a data set from your textbook over here. So click on it and then you will get yourself a data set here. And we are going over to data set number 36. So you click on here for fast food, click on the data set number 36. And I'm going to sign in here because we need to sign in. So I can, this is really rare because usually they will sign in automatically for you. So if you doesn't able to sign in, you make sure you sign in using your SAR ID and your passwords. Okay, like how you sign into your D2L. Now, these are what we call as the context of variables in this data set. We got quite a bit here, but you only concentrate on one. For this case, we will concentrate on the Burger King lunches. Okay, so what you do is you will find the Burger King. So this is like Excel, so you can actually, this is the Burger King lunch, so you can actually move your cell a little bit bigger so you can see it. So our main concentration is this Burger King lunch here. Now, there are around quite a lot of data. There are around 50 data in this case here. So we will need to reorder it. So put them in order from the lowest number to the highest number. So how do we do this? So you can pay attention, class. You just click on to the Burger King lunch. You see there's a little arrow down here. So click on the little arrow and you can do what we call as sort the table by ascending. What do you mean by sort the table by ascending? Means they will take the numbers, the data, and sort it from small to big. Okay. So again, I'll show you how to do this. You go to your Burger King lunch on your mouse and then go all the way top there. And then you see a little arrow here. So click on the little arrow and then you do sort the table ascending way. and there will be, you can do the descending, then you just do it from big to small, okay? But I will actually prefer small to big, so I will do the ascending part. And then now we didn't finish with the question. So this is the one that we are concentrate on. We don't concentrate on other variables in this case. Now in the test, if you doesn't know which variable to look at or which variable I'm asking for, you can always raise your hand and ask me, okay? Hey, David, do you know what variable do we use for question 2 in the test? I will say, oh yeah, we're gonna do Burger King lunch. We are not going to go the rest of it. I will tell you which variable if you need to, but usually it is written down on your test in this case, or in the question, okay? Now, the next part is very important. It says that you will start with a lower class limit of 70 seconds and you use the class width of 40 seconds. So usually the question will tell you where do you start with and what is the class width of it. Now, because of this statement here, you cannot start at 76. Although we know if you look at the data, the 76 is the smallest number we have here, but you don't start at 76 because of the questions mentioned that you actually have to start at 70 instead of 76. So make sure you guys know that. Another mistake students do in my test here is they don't read this question and they start with the smallest number that in the data set. But I will say don't do that. Please refer to this question. Okay, so we do need the context here. So I'm going to short form this as BKL, which is short form for Burger King lunch. And we're going to put this as seconds. Okay. What is this second means? That is your units. So you can tell that every single one here use seconds here. So that means that is your units. Some students ask me that, David, can I skip this BKL seconds? I will say no, because if you look at all the frequency distribution, you always need a context before the classes. So that's why if you don't give me the context of the frequency tables here, you will get a ½ point deduction in your test. Okay, so that means that if I don't give you all this, if I just give you this, then I will say, what does this represent? You know, is that your test score? Is that, you know, temperature? So I doesn't know because you don't give me a context and I don't know what the data represent in this case. So that's why make sure that you must have a context so that your data will, then we know what it means. Okay, so make sure this is important. So that's why you need to have this. So we're going to use BKL here, which is mean Burger King lunch, and for second and frequency. Now, the next thing, the next class or the next line that you're going to do is based on the lower class limit. So it starts with 70. So you will start from 7. Okay, not 76, because I know the data has a 76 here. Don't start at 76. Now, it says that the class width is 40. So this is a lot of students make mistakes. So please pay attention here. So you add 40 to this. So we know 70 plus 40, if you need calculator, you can use it, is 110. Okay, so this is 110. You can use a calculator to do it. So my question is, where do we put 110? This is important. Do we put it on the upper class limit? Or do we put it on the next lower class limit? So where should we put 110?
Lower class?
Correct. Okay. So make sure you understand this. Do not put 110 here. You will get it wrong. And why it's wrong? Do you guys still remember what is the definitions of class width? Here is a definition. Class width is the difference between two consecutive lower class limits. So if you put 110 here, and you know that this will have to be 111, right? Because the number next to 110 is 111. So a lot of students will put 111. But can someone tell me what is the difference between 70 and 111? The difference is 41, which is a class width. But unfortunately, the class width in the question is asking for 40, not 41. So again, what you did, and then if you didn't know this, you start doing all this class, start to record the frequency and everything. I will point out to you that it has a domino effects. What is the meaning of domino effects? If you make a mistake in the beginning, the rest of all this will be wrong. This is called domino effects. So let's say in the test, you make this mistake. So let's say this question number 2 is in your test, and you make this mistake where it's, this is 41, not 40. The whole question, we know is wrong, right? Because it has a domino effects. Will you get a 0 point in your test if you did everything? But we know it's wrong because you start up with a wrong foot, or you start up with a wrong, you make a mistake in the beginning, right? So will you get a 0 in your test? Let's say this question worth 10 points. So will you get a 0 in your test? The answer is no. Okay. For this case, I know you make a mistake. I will take 1 point here. But the rest of the question, the rest of it, I know you make a mistake. The rest is wrong, but the rest is correct based on the wrong mistake you make. So everything is correct. You are actually will earn 9 points in this case. Okay, that means I will take 1 point off for making this making this mistake. But however, if you make a mistake here and a mistake there, so I begin to take a point here or half a point here, and it will add up. So I will take it up from 10 points. So in other words, if you try to do something and it's relevant, but you make a silly mistake or some careless mistake in the beginning, we know everything is wrong. Same thing like math classes you take. I won't penalize you. You won't get 0. Okay, you only get 0 if you leave the whole question blank. You didn't do it at all. Yes, then you will get the 0 points in this case. Okay, so I will say that please do not. I will recommend please don't leave your question blank, because all these things. Because you will get a 0 in the test. Okay, so please don't do that. Okay. So now I'm going to correct you guys. So do not do this. So we should put the 110 right below here. Okay. And then what we do is keep on adding 40 seconds to it. So 110 plus 40, 150. Again, put it underneath. Okay. Add another 40, 190. Add another 40, 230. And add another 40, 270. And add another 40, 310. Now, this is another mistake that students do in my midterms is, oh, I give you so many lines. You keep on adding 40, 40, 40, 40, 40 till it ends. No, do not do that also. Why I say you do not do it is because what is the maximum data in this case? If you look at the data set that is in here, the maximum that you have is 259. So that means that your frequency tables classes cannot be over 259. So you need to begin to take things out. So 259. So again, so these 2 lower classes you cannot have. So you cannot have these 2. The reason why you cannot have these 2 is because it is over the maximum 259. Okay. So please do not do that. Again, the reason why you keep on doing the classes here, it will affect your class midpoint, and also it affect class boundaries. Okay, so that's the reason why that you do not do this. Okay, so just don't keep on going. Although I give you a lot of spaces here. Now this is your lower class limit. So next we will doing the upper class limit. So you do a number that is less than the lower class you have. So 110. So the number that is closest or less than 110 by 1 is 109. Okay. And if you do the next one, 150, the one number that's one less than 150 is 149. And you also notice that if you look at the difference, what's the difference between 149 and 109? It is 40, which is a class width. So that means that if you didn't get 40 on each one of these, something is wrong. And since we know that the class width here is 40, so you can add on 40 in this case. So 149, 189, add another 40 will be 229. Add another 40 is 269. So these are all your, how do we figure out your class with your classes in this case for the frequency distribution. Very important here. Anyone have any questions for me? All right, so the next one we're gonna do is we're gonna tally it up. So so what you do is count. So count how many data falls into this class. So 70 to 109, so it's here. So you can count here. So 70 to 109, I'm gonna make this smaller. So you guys, so I got two screens here. So again, we need a Burger King lunch, which is this fellow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So include 109 because it does end at 109. So there are 11 data in this case. So you will be putting 11 as your frequency here. Now, class, if you don't want to count like I just did, utilize this row. Okay, so you can tell that this is 11 straight away. So because 109 ends at 11. And then for the next class is 110 to 149. So we will be using, oh, sorry, from this n to, I thought they, no, to the 149, which is right here, okay? So usually I will tell my students to take out a calculator. If you want, you can count. So 110 starts at number 12. But 149 ends at 34. So we're gonna subtract this using a calculator. So 34, which is 149, minus 12. 22. Okay, so 34, which is you can tell by looking at. So you just subtract this, and a lot of students will say, oh, 22. So this is 22. Okay. You find the number, find a number closer to 110 because we know this is 110. So a number less than 110 is 109. Okay. Yep. Ask questions if you do, or you can either chat room or. Now, this is, I will tell you that you got this one. Oh, this is 22, right? I just subtract these two. Unfortunately, 22 is wrong. Yes. So I think it's wrong. Let me check. Let me count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's why I know that I think I counted is wrong, really. The reason why is because this is wrong. It's not 22, it's 23. It's because when you subtract 34 from 12, I believe, right? You get the 22, but it does not include 12. Okay. Example is, if I want you to count from 1 till 10, how many numbers are there from 1 till 10? So you say, oh, 1 till 10 is 10 minus 1. I got 9. But you know 1 till 10 has how many numbers? 10 numbers, right? But when you do 10 minus 1, it's 9 because it doesn't include the first number in this case. So that's why when you guys want to do the way that I just showed it to you, you can subtract those the row numbers here, but make sure you add 1 to it because that one additional 1 is the number that is starting that it doesn't calculate for. Okay. So this is kind of a bit tricky here. Otherwise, you just count it by hand like what I just did here. We're going to continue with the next classes here, 150 to 189. So 150 start at 35 row and 189 ends at 41. Okay, so 41. So I'm gonna use my, if I'm gonna do it that way, 41 subtracted by, what is the number we have here? 150. So 150 is 35. And don't forget to add 1 at the end there. So 6 plus 1, so this will be 7. Okay, or you can count by hand. The next one is 190 to 229. So 190, he's 42. 229 is this, so 47. So the answer close to 47. So number 47 row subtracted by 19. What's 190 here? The 42nd row. Again, you will get 5 here, but make sure you add 1. So this will be 6. Okay. And the last one is 230 to 269. Now this one you can count because you only have 3. So we'll do 3 in this case. So this is what we call as frequency distribution. Anyone have any questions here? Again, this is coming up in your test. Next, we will do the relative frequency distribution. And what is the meaning when I say relative frequency? Means that I want to change this to become percentage. So for the relative frequency distribution, I will change this to become percentage. But first thing first, how do we change the percentage? We need to know the total frequency. So one way is you can add all these numbers, okay? The other way is if you are smart enough, you just look at your data. How many total data set do we have? You should have 50. So you should have a total of 50 data set. But otherwise, you can double check your work here. This is something I always tell my students to double check. Just add all this frequency up. You should get 50 in this case. If you do not get 50, something is wrong. Means some data is missing. So now we will begin to do the relative. So how do you figure out the relative frequency? Just take the class frequency, each one, the first one, 11, over by 50 times 100%. So this came out to be exactly 22. And you repeat the same thing for the next class. So 23, which is the class frequency, divided by the total, 50, and then multiply it by 100. So this will be a 46. Okay. The next one is the class 7, class frequency of 7, divided by the total of 50, and then times 100. So this will be 14%. And 6 and 3 will be the next one. 6 divided by 50 times 100. So this is 12. And then the next one is 3 divided by 50 times 100. So this one is going to be 6%. So this is what we call as the relative frequency distribution. Anyone have any questions with this? Right. Because we got 50 data set. Yeah, we got 50 data set here. And in order for you to calculate the frequency, the classes, you have to use the sum of all the frequencies. So for this case, it's 50. So you take all the class frequency for each one, 11 over 50, 23 over 50, and all this over. Yeah. That's how we figure out your percentages here. Depends on the total. Sometimes, like last time, total is 91, so that's why we divide with 91. This total is 50, so we have to divide this with 50. Okay. Next will be the cumulative frequency distribution. So for the cumulative frequency distribution, you need to use 2 columns. one column is the BKL, which is the same thing as what we have, second. And the other column will be your cumulative. Okay. Now, why this you need to use two columns, while the relative you need to use one column? The reason why is because when you do the relative, these percentages that you calculate, we are using the same class as the BKL for the frequency distribution. That means 22% are people wait in line for the lunch from 72 seconds to 109 seconds, 22% of them. Okay, so 46 is this and so on, so on. So, that means that the relative frequency using the same classes for the frequency distribution. Unfortunately, for the cumulative one, you cannot use the same classes. And make sure also you do not use the percentage, you use the frequency to calculate it. So I got a lot of students make mistakes by not building this the classes for the cumulative. So if you remember the cumulative, what you need to do here is you have to use the symbol less than or equals to. So that's why in order for you to build this cumulative, you have to use less than or equals to what is the upper class limit for the first class, which is 109. And you only have 11 frequencies. So that one we don't have to add because so it's 11. But however, for the next class, you will have to use less than or equals to 149, which is the second class, upper class limit here. For this case, you will add these two numbers, 11 and 23. 11 and plus 23 is 34. So this will be 34. Okay. And that means that the 34 is actually not from 110 to 149. It's actually from 70 to 149 because you accumulate from the first class to the next, to the whatever class you're doing. The next one we have in this case is less than or equal to 189. So that means we are accumulating from 70 to 189. So from the first class all the way to the third class. So we're going to add all these numbers. Or you can, because we already add these two is 34, so we just need to add 7 on it. So 34 plus 7 is 41. Okay. And then the next class for cumulative frequency distribution is less than or equal to 229. Again, that means this is measuring from 70 to 229, not 190 to 229. So again, you're going to add all this frequency, or in other words, we re-add these 3 is 41 plus 6, which is 47. And then for the last one is less than or equal to 269. And we're going to add everything up. We know the total is 50. So this will be 50 in this case. So this green that I drawn here is what we call as a cumulative frequency distribution. Questions, anyone? Right, and if you continue reading the questions, the question also wants you to figure out the class midpoints, the class boundaries, and normal. Okay, so I finish up this question. So if you remember how we find the class midpoint by the first question, the class midpoint is you take the lower, the CM that we use here, class midpoint, is 20 plus 29 divided by 2, 30 plus 39 divided by 2. So you get all these class midpoints. So we're going to do the same thing here to find out what is the class midpoint in this case. So in order, sorry, just lost my little. So in order for us to figure out what's class midpoint, you just need to do it across. So add these two numbers, 70 and 109, and then divide this by 2. And I think I told you guys how we do this yesterday in your calculator. Make sure you put a parenthesis around it. Otherwise, you get it wrong in your calculator. Okay, parenthesis 70 plus 109, close your parenthesis, divided by 2. So you will get 89.5. And then the next one, the next class midpoint, you should do the same 110 and 149. So you will do parentheses 110 plus 149, close the parentheses, divided by 2. So this is 129.5. So that will be your next class midpoint. Okay. And you're gonna do this quite a lot of time, but you know a shortcut. If you know, does anyone know what's the difference between 129.5 and 89.5? So if you subtract this from 89.5, anyone know what is that number is? What's the difference between these two numbers?
3.
Not 3, 40. Okay, which is the same as your class width. So remember last time how we do this, we know the class width is 10, right? In the example 1, what we do, we keep on adding 10, right? So this time you don't add 10 because your class width is 40. Maybe, sorry, whoever the person, maybe I misheard you. I think she said 40. So what we need to do is we just keep on adding 40. Now, how many classes do we have in this case? We have 5 classes. So if you read, we got 5 lines. That's why we do need the other 2 extra lines. So we got 5 class midpoint in this case. So that means you can keep on adding 40. So 129.5, if you add 40 is 169.5. And then you add another 40, you become 209.5. And then you add another 40, will be 249. So this will be your class midpoint, and you should have 5 of them. 1, 2, 3, 4, 5. You guys all right? Now I have no room, so I'm going to write it down here. Class boundaries. Now, how do we find class boundary? Now, if you remember how we find class boundary in the first example, we do the diagonals, okay, going from the upper to the lower. So in order for us to figure out what is the class boundary here, we will go diagonals here. Okay, so we go diagonals like this, not the other way. So, so you have to figure out what number is right before 70. Now, you know that this here in the upper class, they all have a difference of 40. So in order for us to figure out this way, you can take the 109 that you have, the first upper class limit, subtract it from 40, because 40 is a class width here. So that is 69. So that means this number will be 69. Okay. So, so how do we figure out your class boundary in this case? You do 69 and 70. Again, parenthesis this. So 69 plus 70 divided by 2. Again, if you use your calculator, this should be 69.5. Okay. And then you do the next class boundary. Again, now you go down to the next diagonal, 109 and 110. So you take these 2 numbers and you add them up and divide it by 2. You will get 109.5. And you notice that, again, the difference between these 2 numbers is 40, which is the same as your class width. So if you do this, you find out that everything you did here is 40, 40, 40, 40. You are in the right track. That means everything you're doing here is so far is correct. But if you find out that the difference here is not 40, 41 or 39, whatever number that is different from the class width given to you here, then you know something is wrong here. So you might need to take a big eraser and start to erase the whole page here. You kind of know that. But if you don't have running out of time, just leave it that way, because I only take 1 point off. Because if you erase everything off and you don't have time to work it on, you probably will get less point than, you know, the 9 points that I told you earlier on. So I would suggest, if you're running out of time, just, you know, you make a mistake, just keep on working on it, because I only take 1 point deduction. But if you do have time, then I would say start over the question again. Okay, so let's keep on adding 40 to this fellow. So you'll be 149.5. I will add another 40 to this, will be 189.5. and add another 40 will be 229.5. Take a calculator, please. That's why you need one. Now, are we going to stop here? Because as you know that there are 5 classes. Now you got 1, 2, 3, 4, 5 class boundaries. Are we going to stop in this case? The answer is no. Okay, I think I told you before that if you have 6 classes, you should have 7 class boundaries. For these questions, we have 5 classes. You should have how many class boundaries?
6.
You should have 6. 1 extra for that. So this, you won't get full points in your test. You have to add the 6th one, which is add another 40 here. You will get 269.5. So this will be the last one. And the 269.5 is actually the class boundary for the last upper with the other low. So this will give me the 269.5. So please be careful with this because a lot of students make mistakes in the test here because they only give me 5 instead of 6. Okay, make sure you have 1 more extra than the other one. Anyone have any questions so far? Right? So the last one they're going to ask us is, do the frequency distribution appears to have a normal distribution? So in order for us to figure out, are they having normal distribution? You look at your frequency, not the percentages, not the cumulative. You only look for the frequency and what is considered normal. For normal, the frequency has to be low and then high and then low. And then after that, it has to be symmetrical. Okay. So what do you mean by low, high, and low? So if you look at your frequency, you start from 11 and then you go up to 23 and then 7 and then 6 and then 3. So this is actually, it goes from low, high to low. So in this case, low, high, low is good. So short form is LHL, which is low, high, low. Your frequency start low and then go up and then slowly goes back down. Okay. Now, how about symmetrical? Again, short form is SYM. How do we figure out symmetrical? We cut on the highest frequency. So the highest frequency we have in this case is 23. This is the highest of the frequency of all this. You notice that this is not symmetrical. The reason why this is not symmetrical is because you only got 1. The other 2 is no. See, in order for it to be symmetrical, you have to have more, like what we just did here. It has to be more. Since you only have 1, but you left with the 6 and 3, so this is not symmetrical. So since this is not symmetrical, so then this is not normal. Okay, so this is not normal distributed. So so that's why you have to fulfill both of these conditions to say it is a normal distributed. Okay. Anyone have any questions here?
On the exam, do we actually need to explain how we got the answer on the low, high, low, and then symmetry?
If the question just asks you for this, does the frequency distribution appears to have a normal distribution, then you do not need to explain. But if the question asking you to this and then explain, then you do need to explain. You got what I'm saying here?
Yes.
Yep. So make sure you read the question really carefully in the test, because if the test doesn't ask for explanation, you do not need to explain to me. Your answer is either yes or no. But if a question did ask you to explain, then you have to explain it out. Okay. Again, if I just ask yes or no, you only get 1 point. But if you guys ask yes and no and explanation, you're gonna worth that question worth more than 1 point because you need to explain the details of it. Okay, this homework is also due on next week, next Wednesday, the June 19th. So again, this is the 4th homework that is assigned, and we're gonna do the 5th homework in here, which is 2.2. So we're gonna do histogram in this case. So what is a histogram? A histogram in this case is a graph. that consists of bar equals that is drawn adjacent to each others. The horizontal scales are for the quantitative data. It has to be a quantitative variable. And the horizontal scale has to be either using class boundary or class midpoint. And the vertical scales are frequency. So I give you an example of a histogram, what it looks like. So a histogram is a graph that on the horizontal scale, which is the x-axis, is going to be using either class boundary or class midpoint. So this number that you use to draw this bar histogram here has to be, if you draw like this, if you draw, this is what it looks like. I will show it to you. Oops, sorry. It's hard to, you guys know what I'm talking about. It's hard to draw here. And let's say I got one more. Okay. So if you do like this, then these numbers that you have here will be your class boundary. Okay. That means these numbers, 69.5, 109.5, 149.5, if you use that example above. But if you want to put it in the middle, if the red one that you see here, right in the middle of the bar here, if you use the middle, then we will use the class midpoint, which is 89.5. For this example, we use these numbers. Okay. And that is your horizontal scale. But for your vertical scales, we will use frequency. Okay. What's frequency? This is the one. That means that this will have 11. Okay. And then the other one is 23. So, I mean, we did this. So again, this is an example. So this is called a histogram. So what you draw here, make sure you know that it is quantitative variable. And all the bar here are stick to each other. There's no gap. Okay. And why there is a gap here? Say, well, David, you said no gap, but why there is a gap in this case? The reason why there is a gap in this case, it means that your frequency for that is 0. Okay, so yes, you can have a frequency of 0. Frequency of 0 means it doesn't have there's no one in that range, in that class. Okay, so that's why it has a gap. So actually, if you draw a frequency, a histogram is a graphical version of a frequency distribution. So what does that mean is you need to have a frequency distribution in order for you to draw the histogram in this case. Yep. I am going to do attendance now. So go ahead and do your attendance. Yep, Maddie, I got you. Yep. So in order for you to draw a histogram, you actually need to have a frequency table. If you do not have a frequency table, you cannot draw a histogram, okay? Unless you do it on your computer, on the StatCrunch. You do not need to. But if you want to draw it by hand, you need to build the table first, then draw the histogram out. Okay. Now, the next thing we're going to talk about here is a little bit different. It's a graph called bar graph. Okay. Now, the bar graph that we have is drawn a little bit different than a histogram. Okay. So this is what the bar graph looks like. Okay. So now I'll tell you what is the difference between a bar graph and a histogram. A bar graph, when you draw the bars, it always have gaps. You see all the bars here, they're separating by little gaps on here, but histogram, everything is all close to each other. So a bar graph, you always have as a gap on the bars. And this is still frequency, which is the same frequency as the histogram. However, your x-axis here is not using class boundary or class midpoints. This using categories. Okay, so that's why for a bar graph, it is a categorical type. What's a categorical? This is quantitative. What we do here, quantitative is numerical, like all this Burger King lunchtime. For example, it's like your grade. So grade in this class, A, B, C, D, F. So these are category. It's not quantitative. And this is your frequencies. That means how many people get A, B, C, D, F in this case. So this kind of graph is called a bar graph. So what is difference between a bar graph and a histogram? One, what kind of variables? Histogram use quantitative, bar graph use categorical. Two, for histogram, they all are lined up, no gaps. For bar, every bar you draw, it has a gap on to separate them. Okay, so that's the difference between a bar graph and a histogram. It's quite important so you guys know which one is which, especially I would like to ask some questions like this in your test. Describe or tell me the difference between a histogram and a bar graph. Okay. Now, the next one we bring it up is the word relative histogram. And as usual, if you remember what we did in the frequency distribution, when you bring up the word relative means you change them into percentage. Same thing happens here. So when you want to draw a relative histogram, you will change it to be your frequency to become percentage instead of actual frequency. So that means that if you change this into percentage, then we don't call this as a histogram, we call this as a relative histogram, okay? So that's the only difference between a histogram and relative histogram is changed to percentages. However, your graph, it looks exactly the same. That means that the height of the bars remains the same no matter if you use frequency or you change it to become percentage. I can show it to you here. So example is if you want to draw a histogram of the Burger King lunch that you have here. So you hit graph, you hit histogram, which is right on the fourth here, and you pick Burger King lunch. Okay. Now this is the type that you see. So if you use frequency and you can change to relative, I will show you frequency first. You hit compute. So this is the Burger King lunch based on the frequency. Now, that's why you don't need to draw it by hand. Usually StatCrunch will do it for you. If you move your mouse towards the histogram and leave it there, they will tell you that this frequency for the third class from 125 to 150 means this is 125 and this is 150. There are 15 frequency. And if you move the first class, 75 to 100, you got 77 frequency or seven people, seven data, and so on, so on, so on. So this is frequency. Now I can change. So I'm going to change the frequency to relative. I want you to look at the shape. Remember the shape? Is that the same shape? You find out the bar height is exactly the same. The only difference is for this case, it's no longer frequency, it's relative. Now for this StatCrunch, they don't use percent, they use decimals. So that means that for the first class, instead of 14% is 0.14. You guys see me here? And so on, so on. And the next one is 24%, or in this case 0.24. So for your StatCrunch, they don't convert the decimals to percent, they just put it in decimals, which is fine because percentage and decimals are similar. So that's why you find out that is the only difference you see in this case. Okay. Now, how do we interpret the histogram? In order for us to interpret the histogram, you use CVDO. So first, you figure out what is the center that is considered the C. So for this case, usually we will use what we call as the mode. Okay. What is mode stands for? Mode means is the highest frequency. Okay, highest frequency. So for example, for the bar, for the histogram that we just did on the StatCruncher, we know this is the highest frequency. Now let me change it back to frequency, not relative. Let me change it back to frequency so that you will see. So a lot of students, this is the highest frequency. So a lot of students say that the mode for this case is 15 because the highest frequency is 15. That is wrong. Let me repeat. A lot of students say the mode for this is 15. That is wrong. The mode in this case is actually from 125 to 150. So you don't use the number on the frequency when you mention mode. When you interpret CVDO here, you use the number on the x-axis. Okay, so we are using mode, which is called the highest frequency. And sometimes you got two highest frequency, like two bars, almost 15 and 15. Then you will have two modes. So, or sometimes you have three bars the same. So depends on how many bars that you have. If you have one mode, you have more than one, you got more than one mode. Okay, so depends on the question. That's for C. For V, the variation, we will use the range. Okay. What is range in this case? Range is you take the maximum minus the minimum. Okay, that's your range. So for example, for this histogram, the smallest number is 75. The highest number is 275. So what you do is you subtract that. So 275 minus 75, the high minus the low, you get 200. So that is the range. So the range for this histogram is 200. Okay. That is how we take care of the V. The shape of the distribution is called D distribution, the shape of the distribution. Now we will have a few shapes that you will learn in this class: a uniform shape, a skew to the left shape, a skew to the right shape, and a normal shape. Now we talk about the normal shape because a normal shape on a bell shape, it means that your frequency goes from low and then high and then low, and then it is symmetrical, what we just mentioned about that you learned. And you can tell that by looking at this. Is this normal? This is not normal because it is not a bell shape. Okay, it's not symmetrical. However, you can tell that this is slowly tapering down on the right side. See that? So this kind of shape is called skew to the right. The reason why it's skewed to the right is because your bar is slowly taper off on the right side. Okay, so this is the example I will point it out to you. So when you have skew to the right, your graph will look something like this. That means that your tail, call this your tail, is on the right side. So this is called skew to the right. Skew to the left means the other way around. That means that your tail is on the left side. Okay. Now, what is meaning of the word uniform distribution? Uniform distribution means that your bar, all the bars are kind of the same height. So if you get a bar that is kind of the same height, then we call that as a uniform. Now, this is what we call as the shape of the distribution. Now, so far, you only learned 4. There's a lot of shapes here, different shapes of distribution, but this class, you learn 4. So make sure you guys know the normal means if you get a histogram that looks kind of like the same height of the bars. Skew left means that you will, mostly everyone is on the right side. You got a tail on the left side. Skew to the right is the other way around, and normal means low, high, low, symmetrical. Okay. Now, so you can tell by the graph that we have on this case, this is skewed to the left, to the right, sorry, to the right, because it is tapering on the right side. Okay, so this is skewed to the right. And lastly, we will mention for O is the outliers. Okay. So far I haven't teach you how to find outliers, so we're gonna use our naked eyes to see the outliers. So I can think about this last bar will be your outliers because it is quite far away from the rest of the data. Usually when you have skewness, when you skew left or skew right, the outliers usually found on that tail side. Okay, so the outliers usually found, because those outlier is the one that push the tail to the left or push it to the right. So that's the reason got the tail. So the tail part in this case usually is where the outlier exists. So you will learn how to find outliers in next week, 3.3, the section 3.3. So this is how we interpret this histogram using CBDO. Okay, so we're going to talk about some examples we're going to use. So we know the uniform distribution, which is everyone's just have the same bar, right? What examples in the real world that will give us a uniform distribution? Example is when you roll a dice and you record the outcome. Now you know that when you roll the die, you got the outcome can be 1, 2, 3, 4, 5, 6, right? So you roll let's say roll the die 1,000 times. Okay, a lot of times. So you take a dice and you roll 1,000 times, and every time you roll, you record what is the outcome. I will guarantee you that your histogram will be a uniform shape. Why I say it's a uniform shape is because this number is very close to 1 out of 6. Because you know the chances of you getting a 1, 2, 3, 4, 5, 6 is 1 out of 6. So that will be very close to 1 out of 6 times. Okay. So another type is your speed of the car in cruise control. I think you guys know what a cruise control is, right? So if you set your car in the cruise control, your speed is remaining 70 miles per hour, example. So your car will be stay on 70 miles per hour, which is called uniform. Okay. So these are a few examples that is uniformly distributed. What is the example that is skewed to the left? Skewed to the left means your tail is on the left side. Example will be like an easy test. So if I give you an easy test, so what happened is a lot of students will do really well on the test. This is a test score, but some students will not do well. This is typical. Even though it's an easy test, we will have a selected few students will not do too well. Everyone will be doing good. Okay. Another one is doing like something with age, because as you guys know that when you get older, our health get worse. So like eyesight, like your bone structures, your listening, right? So that means that your people who have bad poor eyesight usually increase when they get older. But there are still some young people who has bad eyesight, right? Not a lot, but majority of us will be who getting old. The eyesight or your bone structures or your teeth or whatever you want to call will get bad, right? So so mostly on the older age will be getting more. So this is kind of a skew to the left type. Skew to the right is the one that is the outliers on the right hand side. So if this is an easy test for the skew to the left, a skew to the right will be a hard test. So if I give you a very difficult test, that means you guys bombed the test, means that a lot of you guys did poorly, but still there are some couple, 2, 3 of you will be doing really well. So usually that happens. So that means that if I draw a histogram, your histogram looks something like this, means the test is hard. Income will be the other one. House price will be the will be also some examples that is skewed to the right. What do we mean by income? Means that your salary. So our salary is here, right in here. Even my salary is here. But you know that there are some people earn millions of dollars salary, but not a lot of them. But mostly of us is in here. Same thing with a house price. Mostly all our houses is worth $100,000, $200,000, $300,000. But there are houses worth around 1, 2, 5, 10 million. But the houses worth those price is not as frequent or higher frequency than the one that is 100, 200, 300. So those are skewed to the right. And for the normal case means it's a normal shape. About this one. Example for this will be your IQ score, height, weight, average tests. So as you guys know that if I give you an easy test, the histogram looks skew left. Hard test, the histogram skew right. If I give you an average test, it will be normal. Normal means that majority of you will be in the middle. Some of you will do well, and some of you will do bad. Same thing with IQ score, your height and your weight. Height means majority of us is in the middle, between 60 some inches to 70 some inches. But there are people are super tall and there are people super short. But those people are not, less frequent in this case. So those are the 4 different types of distribution in this case. And I will add one more distribution. It's called a bimodal distribution. Bimodal distribution means you will get 2 modes. That means that in your what happens to your bimodal distribution for the histogram means you get like 1 and then you get another 1. So this is what we call as a bimodal, means that you will get 2 peaks or 2 highest bar here. So that is called bimodal distribution. You will see some examples on the bimodal distributions. That is, you got 2 peaks in this case. Example will be like usage of highway. Example, highway use, cars, let's say cars versus time in the highway. So you know that on a weekday. Example. What I mean in this case is like today, if you go to use a freeway between 8, 9, 7, 8, 9, 10 p.m., you do not want to use it because everyone's going to work. So it's high. And then between 10, 11, 12, 1, 2, 1 o'clock, 2 o'clock, the frequency of the car using that freeway is not as high. But then after 3, 4, 5, 6, 7, the frequency is high back again because everyone is returning back to home from work. So on a weekday, I'm talking about. So this is kind of what we call as bimodal, means that you got 2 peaks in this case, or 2 highest frequency. Okay, you guys all right here so far with the shapes? Quite important here. So how do you draw a histogram using a StatCrunch? I show it to you. I'm going to show it again. So, yep, I got the questions coming up. Okay. You got questions, Corinne? So I just mentioned how you draw a histogram here. Hit graph, hit histogram, and pick a column in this case. Okay, sorry about that. We do the beginning lunch, and you just hit compute. This is the fastest way to build it. If you do this, you let StatCrunch to in charge of your class boundaries. Remember, these numbers are your class boundaries here. Okay, but you guys remember the histogram that the frequency distribution that we built here. We have selected class limit and we have a class width. That means we fix like this. This is kind of a freehand. That means your class your StatCrunch uses its own idea to do it. But if you want to have a special class, then you have to do something here. Is you have to, what is that frequency? Nope. Sorry, I'm looking at it. Nope. I think it's down here. Sorry, I'm looking at, where was it at? Custom, add custom. Nope, 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 nope. Let me see. Sorry, that should be right over here. Relative histogram type, pick a word, compute. Bins, I'll look at bins, sorry, that would be bins. I think it's way down here. Let me see, I cannot find it. Where is the bin? I don't see bin. Burger King lunch. There you go, bins. There you go. I see it. Partially blind here, David. So bins means where you start at. So we start at, if you look at the question, we start at 70, right? If you remember this fellow, it start at 70. And the class width is 40. So if you want to draw exactly the same, then you have to start between 70. The class width is 40. With the Burger King lunch, with the frequency, if you hit this, this will be exactly the same as your example that we have. So if you hover this to your first one, it's 70 to 110. It is, I'm going to show that side by side so you can see the frequency we have. So if you look at this with a, so 70 to 110 is 11. So 70, 109 is 11. So if you notice about when you hover around, you see that in the Burger King lunch, they got the brackets and the parentheses. That means that the bracket means it's including 70. The parentheses means you're not including 110. That means the closest number close to 110 is 109. That's why they use a parenthesis on that way. It means that it's not including 110. So that we have 11. So we do have 11 here, frequency. And then when you go to the next one, 110 to 150, not including, is 149. You got 23. So you got 23 here. And 7 on the next one, 6 on the following, and 3 on the last case. You guys see that? Okay. So make sure you understand the brackets means you're including that number. If you don't have a bracket, means you're excluding the number. Okay. So next is my question is, so now you got this histogram for this Burger King lunch. Let's say I got one guy. So you go into Burger King's today for lunch and your waiting time to get your food is 110 seconds. Exactly 110. So where should we, 110 is right in here, right? Right in the middle here. So where you think we should put this 110? Is it on the first class or is it on the second class? Anyone? Let's say you got. Okay, let's figure out. So this is 11, this is 23, right? So let me put in another number, which is 110. Let me reconstruct this. Anyone know which one, the first or the second? Someone say first. So let's see that. So let's go to the graph. Let's do the histogram. Let's do the Burger King lunch again. Let's do 70 again, and then 40, same what we just did here. Let's hit compute. So where is it at? Still 11 on the frequency, but how many on the next one? 24. So actually, if your data is smack right into this class boundary, it will go to the higher one, or on the right side class. Okay, not the first, the next one. You guys okay here? Right, I'm gonna delete this fellow and I'm gonna recall them to draw this graph. So this is actually for question number 1. So question number 1 is asking us, use the frequency distribution from 2.1 Burger King lunch to construct a histogram. So this is the histogram. Now, I will show you the quite easy way. You can actually copy and paste this. So I'm going to copy this whole thing and paste it. Copy image, paste image. Where's my friend paste? Paste it over here. Sorry. So you can paste, yeah, you can copy and let me see, copy, save image. I cannot copy this photo. Oh, this is in PDF. Hello, that's why you don't let me paste it. Sorry about that. If it's Word, yeah. So you can copy and paste it. So this is your picture looks like in here. Okay, again. So this is the Burger King lunchtime. So you actually do not need to draw it by hand. You draw it by StatCrunch. But the question is asking, what shape of the distribution is this? Is this uniform? Is this skewed to the left? Is it skewed to the right? Is this a normal shape or is this a bimod? Anyone?
Skewed to the right.
This is skewed to the right. Yep. So again, so this is skewed to the right. So this bar, just copy this and paste it over there. Okay. So we're gonna do a little bit more. I know it's almost time, so we're gonna finish out this question 2, and then we will be then you guys can finish your homework. So again, this homework is due by Wednesday on the 19. Okay. So question 2 is referring to this graph. So I know it's a bit hard to read. You're asking is this histogram is the weight of the quarters in grams to answer the question below in this case. Okay, I'm gonna try my best if I can make this bigger. Finding this. I want to make him bigger. Is that Control Plus? Yep, there you go. So you got it bigger now, you can see it. So what is approximate number of quarters in this case? So they're asking for how many quarters are used. So if you remember, if I give you this, how do you figure out how many people? We know we got 50, right? So you just figure out what is the frequency for each one of this, and then you add them up, 11, 23, and so on. So same thing happens for this case. If you want to figure out how many numbers in here, so you figure out how many frequency in this case. And you can use approximation, means that's why you use the word approximation. So that means you don't do exact. So can someone tell me what is the frequency for the first class here? This is around maybe 12 or 13, something like that. Okay. This one I think is 20, right? Or 19. This one is I think 8 or 9. So I'm not penalize you if you give me a 1 off or 1, plus minus 1. This fellow looks like 5 to me. This one's a little bit shorter than the 20. I think it's 19 or 18. This one looks like 14. Again, I'm just, oh, we do not need to use this. I didn't read the question carefully, David, because the question here does not include that. The question is asking for the first 3 bars on the left. So the question is asking for just these 3. Didn't read the question carefully. That's why. So what you do is we got these 3. So we just add these 3 numbers up. 20 plus 12 plus 8. So there are 40. So this is around 40 quarters in this case. Again, if you give me 38 or 39 or 40, 41, 42, I'm still give it right because this is approximation. Okay. Question B is asking for what is the class width. Okay. So in order for you to figure out what is the class width, this is your class width. So remember last time, if you look at the histogram here, 70 to 110, you find the difference between these two. That is your class width, which is 40. So you find out each one of these is 40 because the class width is 40. So how do you figure out the class width in this case? You just find the difference between these two numbers. So 5.6 minus 5.5. So that means that your class width in this case is 0.1. Now make sure you know the units. It's not quarters. The unit here is grams. So this is your class width. Okay. But the question is not done yet. It also asks you for lower and upper class limit for the first class. Now, this is your first class, the one I shaded in green here. First class means your first bar. This number is your lower, and this number is your upper. So your lower class limit, in short form here, is going to be 5.5 grams. However, your upper class limit is less than 5.6 grams. So do not use the word equal to 5.6. The reason why you cannot use equal to is the same thing we just mentioned here. If you look at this fellow, 110 is not included, but any number that is below 110 is included because 110 is in the next one. So for this case, you cannot use 5.6, but any number that is below 5.6, it will be your upper class limit. So be careful with this case, okay? Not equal here. Questions, you guys? Next, they want you to figure out the shape of this histogram. So the shape of this histogram in this case will be a bimodal case. Why this is bimodal is because you got 2 peaks. Now I know this peak is a little bit shorter than the other one, but it's still considered 2 peaks. Okay, so 2 peaks means bimodal in this case. And for the last question, why? Give me a reason why there is a gap in the middle. Okay, so do not tell me. A lot of students explain in the test or in your homework saying that the left side is less weight, the right side is heavier. Yes, I know, I can read this histogram. And then I say, oh, there's no, some students explain there is no quarters between 5.8 to 6 grams. I understand. The question didn't ask you to read this graph. The question asking to you why there is a gap in the middle of it. Now, you know, this is the weight of the quarters. So one of the reasons is because of the age of the quarters. So you can tell that usually I'm going to type this out because it's quicker to type it out than to write. Sometimes old quarters weight more than new quarters. So you can find out that if you have any old quarters, if you measure it, there will be around this weight, 6.1, 6.2, 6.3, 6.4 grams. But if you get the new quarters, it is you're gonna weight a bit less due to the material. So materials right now, when they make quarters, they use lighter material. And based on the old quarters, they use a better, more nice materials. That's why your old quarters actually worth more now than the new quarters. So that's the reason why there is a gap in this case. Now, some students was like, but David, this is something that is not teach or not, this is you had to learn. Why come up these kind of questions in your test? The answer will be no. So you won't get this kind of questions in the test here. The reason why is because I won't ask you this type of questions in the test. I will ask you A, B, C, but not D. You will probably get question D here in your homework. Okay, so this is the end of today's class. I know I've put a few more minutes today here. So you do have 5 homework due to on Wednesday night, which is chapter 1, chapter 2.1 and 2.2, 5 sections of them. So make sure you guys start working on your homework here. Okay, so I'm gonna stop sharing and thank you for staying a little bit later today.